Welcome to a new test and teardown video. This time we are down on the floor. I'm so sorry, but this thing is just way too big and way too heavy to lift up on the table all by myself. Oh, this is so big. This is a general radio wave analyzer model 736A. It was originally advertised in 1939 or something like that. So it is really, the design is that old. I also find some advertisements from 1950. So it can also be from 1950s. So this thing, well, it is just a frequency meter and the harmonics, obviously. So the big wheel here, the big dial, is where you set in the frequency of interest, and it goes all the way from 0, as you can see. And this will be in kilohertz, as you see here, in megahertz, and it stops at 16 megahertz. And it is a super heterodyne design, so it mixes down the incoming signal to a 50 kilohertz signal, as far as I've been able to figure out. And then it detects this, and it can couple this via 3 crystal filters, and then it can detect the level, and then it can read out the level of of course, the bass frequencies and all the harmonics and all that kind of stuff. So this is how it is, a manual frequency analyzer, just like a spectrum analyzer, but it is called a wave analyzer because it's done manually. You analyze it and you tune for the frequency you want to analyze, right? So the size of this thing, I don't know if you can see that. It is 50 centimeters wide, 25 centimeters deep, and 64 centimeters high. So that is a volume of 80 liters. But the weight of this unit is 40 kilos. So let's imagine this was a glass and we filled it half with water. Then you would have the weight. I mean, that is amazing. But I have to open this first and inspect before I can power it up. And we have another little problem. There is a broken knob right here, but I happen to have that broken knob, and it's a Bakelite, obviously, kind of crusty material. So that is broken, and also the shaft is made of Bakelite, but with a hole, so it can easily break. Maybe I can fix this somehow. The knobs with exactly this design, that is quite a normal knob back in the 50s and even up in the 60s. Everybody loved knobs with exactly this design. So I happen to have quite a stock of knobs with this design. So I hope I can find some this big so I can repair this. But anyway, let's try and open this thing. So I'm here, still on the floor, crawling around to avoid lifting around on this big hefty unit. That is the rear plate that makes sure you get plenty of air in here. Obviously that is good because it's tube based. But that piece of metal here, just this piece of back plate, is 2.5 kilos alone. It is really thick and very, very heavy. So when I opened this thing, something fell on the floor. And that was a tube. So that is the first little problem. Yeah. Let's just wait a little second with that one. Because obviously this thing was thrown out. So this, ooh, is it supposed to be like that? This I can easily repair, right? And I bet it reads 6C5. 65. Okay, so that is good. So far, so good, right? And then I should give you a little bit of light in here. So we've got some more tubes that's halfway out the sockets. That will be some of the voltage regulator pentodes and another voltage regulator. And I thought we were looking at some rectifier diodes, but that seems not to be the case so far. Maybe that one down there, but this is selenium rectifiers, right? And voltage regulator neon bulbs, those 3. And yeah, quite a lot of tubes up here. And then we got one more down here and 3 big tubes. And there is down here. This is also fallen off. So and to put this back on, I need to take it out and figure that out. Oh yeah, that is also what I figured. Look at that. And there is a ECH4. I really don't like those side connectors. But this is like the 1940 style. So this reveals that this unit was definitely designed in 1940 and 50. This is really old kind of style. And there is a connector for that one. Yeah, okay, here we go. That one up there, right? So it's hanging down. So yeah, I have to stick that in there. And another funny thing about this case is that it is very big wood, and they put on a thin layer of copper, and they're using some copper nails as well. Here, everywhere, copper nails. Oh, that is just nice. But I still don't really find the 40 kilos. I can't really explain why is this 40 kilos heavy. There's a very big capacitor here and thick metal all the way around that. Yeah, we got a lot of thick steel here. And I would assume this is so you can take out everything out the front and then put it on your table, and then it will stand on this part. And then there will be a nice balance. And look, we also got these funny metal sticks here, each side. And I would assume if you take this whole unit out the front, those two together with this piece, that will make it possible to put this flat down on the table so you can do service with the front up. But anyway, I will have to take it out of the case and pull it out the front. Whew, that was some hard work. You need to lift and do some nasty stuff here to maneuver this out, and the screws just you can't press the screws down and then... Oh, damn it, that was difficult. But anyway, it is out. And this wooden case, I just put it on my scale, and that is another 7.7 kilos. And by the way, there's a really nice text label here on the top. I should probably put in a little picture here so you can see this fantastic label. That is some important information. You can see all those many years added. Some signs. And also this thing is dirty. I'm probably gonna go and put it outside and give it a little bit of compressed air. But this is still, what, 29 kilos or something like that, isn't it? Yeah, 29.2 kilos. And I really can't see, why is it so heavy? Maybe it's because the front here is really thick. What are they doing good for? Making it heavy. That's what they're doing. After my deep clean of everything, paintbrush, cotton buds, compressed air, water, and everything, it is getting so nice and beautiful and pretty and clean again. Look at all that. I still find it a little bit funny about the weight. I mean, if you look at all this here, right? I know this is 29.2 kilos. So where the heck is all that weight? The front plate here is 6.5 millimeters thick, and it is 48 by 62 centimeters big. So that means that is 5.35 kilos just for this piece of metal here. Everything else is also made in aluminium. So it's not really a super heavy piece of metal, but where's the rest? So we need 25 kilos left if we even remove this one. And I don't find that, really? Where's all the lead? I don't find it. I haven't looked inside this box yet, but that is my next move. So I took out this case here, and I think that is tinned brass as well, so that was also quite heavy. And look at that switch. That is one beautiful switch, and that is the one that is broken, by the way. So somehow I need to figure out how to repair that one. And that is one big variable capacitor, and it's a very special one, by the way. Look here at the end. Here is a calibration system with the screws. So all those screws here, that's what I'm talking about, right? Oh. So you can calibrate all the ranges to go perfectly fine. That is, of course, a very heavy component, but again, and that will be the 3 amplifiers, I think. Here is a problem that prevents me from powering this up. What you see here is burned leakage from those two capacitors here. They actually melted all the way through the metal, as you can see here. So this is not so good. And the other capacitors also reveals completely leaked. So yeah, I'm sorry, but I can't really power it up. But I still found it a lot of fun to look at everything in here. How is everything designed and built and all that? It is really fantastic. So that will be an internal calibration capacitor. All the knobs and stuff here, that will be for the calibration and setup. Don't you just love this capacitor here? Oh, that is some kind of fine adjustment. Super fine. Oh, that is super crazy. Ceramic and all that. And then they got this piece of metal going that close to the capacitor. And by the way, all the pieces here is either aluminium or stainless steel or something. None of it is magnetic, not even the screws anywhere. It's all non-magnetic components. Since I can't power this up because I don't have these capacitors and I don't have schematics or anything like that, it doesn't really matter so much just to see this peak at some frequencies or all that. Of course, it could be fun to see if it's working, but then I definitely want to have a look inside the. I think that will be the 3 crystal filters or some other components for that, because I don't find anything else that could look like a filter like that, right? See? That will be the frequency stamped into the side of these, so I bet that is it. And they are sealed with some stuff that is really disgusting. So I need to go and find a vacuum cleaner. And we also want to have a little look inside the little metal cans like that. I was, of course, able to open one of these filters, and those are definitely the 3 crystal filters. Let's get some more light. Look at the beauty. Huge crystal filter. I think I've never seen a crystal filter this big before. And those tiny wires. It's because it's actually moving. It's vibrating in here. So that is why it is inside these big, massive aluminium boxes. See, and we got some handwriting on those units. Oh, that is cute. So yeah, we found it. That was only a choke coil. So this is just for filtering high voltage. And nothing big and fancy smancy in that one. I just wanted to show you a little detail about those metal canned tubes. Of course, the other metal can here is grounded. It's connected to chassis, right? Using the socket. So the top here is of course also ground. And look at the way that this piece of shielding material here. So this cap go and shield. This is a critical signal, and you don't want this to pick up all sorts of hum or something. Quite nice, huh? I'm still looking inside all the different cans here. I bet that one is the inductor for the oscillator that goes together with the big, beautiful capacitor. And that is, of course, inside a nice shielded box. Imagine the way that they made these boxes back in the 40s. A machine presses this material up to this shape. I'm a little bit impressed by that, by the way. There's I keep finding stuff that is broken, by the way. See this variable capacitor here? It's written 15 micro, and that is, of course, pico. I really don't like that way to say that, but you can see the scratch marks. So that means I don't know if you can hear that. Yeah, here. So there is a short in that part, so that is definitely not good for the oscillator trimming. Oh yeah, there's another one over here. Another one of those beautiful cans that's hiding the inductors. Everything is, of course, hand-made. Quite nice. So I'm done cleaning up everything here and fixing as much as I could. It is now nice and clean for a future restore and repair project, maybe. We'll never know what the future brings. So I don't have a lot more to add to this video. I will write down all the tubes, so there will be a complete tube list in the description, so you'll get the idea about what this consists of. So thank you very much for watching this oldie. Definitely one of these really oldies. I really like the design of this area here. So much 1940 with this type of sockets. You mount this on the bottom and then you're just done. Wire up everything, done deal. And then later on we have these sockets here mounted from the bottom and then wires on the bottom. But this was the old classic way to do it.